Today we are starting a brand new chapter, which is exciting. We're finally talking about circles. Circles are really cool shapes. I'm hoping that what pops into your mind when you think of circles are, there's certain vocab words, like in my classes when I taught this today, like radius came up a lot. And I also was asking people for, try and think of some examples. Like, where do you see circles popping up in your day-to-day life, right? These are shapes that we see all the time, but we haven't really thought about too much. And I've been discussing with my classes today, what is the real difference between a polygon, so squares, triangles, pentagons. What's the difference between these shapes and circles? What's the real difference? And people have been able to tell me, well, circles don't really seem to have any sides, Mr. Card, and that's true. Circles don't have any sides. So if they don't have any sides, how do we draw them? How do we qualify them? How can we be so sure what is and isn't a circle? So let's get into our definition. The definition of a circle, right? A circle is, if I can move this. A circle is, whoa. Okay, there we go. A locus of points, meaning it's just a collection of infinite points here. Infinite points, right? I could fill in the space between here with infinitely many more points. And as I keep filling it up with infinite points, those points become, it just seems like this solid line where what all the points have in common is that they are equidistant from the center. So it's a collection of infinite points. All of them, what they all have in common is that they're the same distance away from a certain center point. That's what makes a circle. A radius is the distance from the center to the outside of the circle. Any point on the outside of the circle is part of the circumference. That is the term for the measurement of distance all the way around the circle. So the circumference is the collection of those infinite points. And the radius goes from one of those infinite points to the center. That is what makes a radius. So if there's infinite points, then there's also infinite radii. That's kind of an important piece to remember as well. The diameter, which will always be twice the size of the radius, right? Radius here, so it's twice the size of the radius, is a segment whose endpoints lie on the circle, so endpoints that are part of the circumference, got it. And the midpoint is the center of the circle. So because it's guaranteed to be from the center to the outside, that's what guarantees that it's 2 radii, right? Because we know that from the center to the circle is a radius, and if that's happening on either side of this, then that makes the center the midpoint, because if the radii are automatically the same as each other, then those segments are automatically congruent. So there's also technically infinite diameters, right? Because I could go through the center, right? And that's enough slices, okay? So moving on to more vocabulary. Let's talk about a chord. A chord, so a diameter is technically also a chord, because a chord is just saying you're just going to connect one endpoint of a circle to another. That's it. Whoa. Just one endpoint of a circle to another. So technically speaking, the diameter is also a chord. It's just the most special and relevant type of chord. And anything else just qualifies as a chord, not as a diameter. But if you're connecting 2 pieces of a circle, if you're connecting 2 pieces of the circumference, you're guaranteed to be making a chord. So moving on. Oops. A secant is just like a chord, except that it's a line as opposed to a segment. I don't want to say that secants aren't that important, but frankly, they're not that important. We just don't talk about them nearly as much as we talk about chords, or the next thing that we'll talk about, which is tangent lines. Think about what it means when Mr. Card goes off on a tangent. It means that at one point I was connected to the topic at hand, and then I started talking about one thing, and it got me into the next thing and the next and the next thing, and before you know it, I'm not connected to the regular topic anymore. So a tangent line is a line which only really connects to our circle one time. So there's no the line, a good way to think of it is it's a line where there's no interior points of the circle are crossed through, right? That would be a secant. That goes where these points are all in the interior area of this circle. With a tangent, I'm never in the interior area, not once. Common tangents are pretty cool, right? Anytime you have two circles, there's going to be at least one, but basically multiple opportunities for common tangents, which is exciting to think about. So this is all the core vocabulary. It's kind of all they really want me to cover in the first part of the section according to the textbook. But I figure we might as well at least introduce some more vocabulary that we're going to get into later. So I'll talk more about these things later. You don't need to be too worried about them right now. But the things we're going to talk about are an arc. So if you think of a circle as a pizza, the circumference would be all of the crust. An arc is just part of the crust. And so there's automatically a minor and major arc where, like, if you remove the piece of pizza, you have this major arc of all the crust that's left, and then the minor arc, which is the crust of your actual slice. And we can measure it in degrees or in actual distance, but definitely think of it as like proportions, where like, and again, this is stuff, you don't need to know this yet, but this is called a central angle. And if this is 30 degrees, then that makes this a 30-degree arc. Really, all that's trying to tell you is, look, 30 out of 360 is 1/12. So the fact that this is a 30-degree arc just means that it's 1/12 of the circumference. That's all you're really trying to say. And then the next thing that we'll talk about is a sector. So if the crust portion is called an arc, this is the actual slice. What's the area within the sector? Again, it's really going to be a proportion. You just figure out, well, what are the degrees in here? You know, if it's 180 degrees, that's half the circle, so that must make it half the area, right? That covers now a large portion of the vocabulary, like 90% of the vocab that we'll learn in this entire chapter. For credit today, please take a blank piece of paper, and you don't have to repeat every definition, but have a circle. That's a terrible circle. And try to do stuff like, be like, if you, like, color code it. Like if this is the radius, you know, right? Radius up in the corner in yellow is like a little key, you know? Diameter, stuff like that. Give yourself a little cheat sheet to use, all right? But that wraps up this video. More to come.